This is question 4 of the SACE Stage 2 Physics course companion from Subtopic 2.2, Motion of Charged Particles in Electric Fields. Here we have two parallel plates and an alpha particle entering 3 centimeters above the negative plate at a speed of 5.2 times 10 to the power of 5 meters per second. What we need to do is calculate the magnitude and direction of the electric field between the plates. This is fairly straightforward. It's using our expression E is delta V over D. Here the potential difference between the plates is 9.5 times 10 to the power of 3 volts, and the separation is 3.6 centimeters, which if we substitute into our calculator we get 2.64 times 10 to the power of 5 volts per meter. Now the direction is the direction that a positive charge would move if placed in that field, and so here a positive charge would be attracted towards the negative plate, so here the direction is towards negative plate. Okay. Part B is fairly straightforward as well. Here we just need to calculate the acceleration of the alpha particle. So just using our expression A equals EQ on M, we've just calculated the magnitude of the electric field. So that's just 2.64 times 10 to the power of 5. Charge of an alpha particle is in the question if you're not sure about it. So that's just the charge of 2 protons. So that'll be 3.2 times 10 to the power of minus 19 coulombs, and the mass of the alpha particle was also in the question, so the 6.64 times 10 to the power of minus 27 kilograms, which if you substitute into your calculator you get 1.27 times 10 to the power of 13 meters per second squared. Alright, part C is to determine the time taken for the alpha particle to reach one of the plates. So here we're not told which plate it is, so we have to recognize it's going to be attracted towards the negative plate, and then this just becomes a fairly straightforward Vovat's question. Here the velocity of the alpha particle in the direction of the acceleration is 0. I don't care about V at the moment. A we've calculated to be 1.27 times 10 to the power of 13 meters per second squared times what we're trying to work out, and the distance will be 3 centimeters. And so using all this, we use one of the Vovat's expressions, S equals V naught T plus half AT squared. Since V naught is 0, this just becomes S equals half AT squared, which we can rearrange easily for T. So T will become just 2S on A square rooted, so 2 times 3 times 10 to the power of minus 2 divided by our acceleration, 1.27 times 10 to the power of 13 square rooted, which happens to be 6.87 times 10 to the power of minus 8 seconds. Alright, so part D, calculate the horizontal distance travelled by the alpha particle before it reaches that bottom plate. So here we're just using the same expression as we would for projectile motion, so D equals Vt, the initial horizontal speed of the alpha particle 5.2 times 10 to the power of 5, and the time we've just worked out, so that'll be times 6.87 times 10 to the power of minus 8. And that happens to be 0.0357 meters, 3.57 centimeters. Finally, part E, we need to calculate the magnitude of the velocity of the alpha particle as it strikes the plate. So here, we need to work out the vertical component of the velocity as it strikes the plate, then use Pythagoras' theorem to work out the total velocity. So here, this is one of the other constant acceleration formulas. We have v equals v0 plus at. The initial vertical speed is 0, and the acceleration is the 1.27 times 10 to the power of 13. And the time we calculated before, so 6.87 times 10 to the power of minus 8 seconds, which if we substitute into our calculator, we get 8.72 times 10 to the power of 5 meters per second. So now we know that the horizontal speed is 5.2 times 10 to the power of 5. The vertical speed is 8.72 times 10 to the power of 5. What we want is this component here. So using Pythagoras' theorem, that'll just be the square root of the sum of the other ones squared. So 5.2 times 10 to the power of 5 squared plus 8.72 times 10 to the power of 5 squared, all square rooted, which if we substitute into our calculator, we get 1.02 times 10 to the power of 6 meters per second. And there we have it. So this wasn't too bad. It started off fairly easy, calculating the electric field and acceleration. Calculating the time taken to reach the other plates, fairly straightforward. The hardest bit's likely the rearranging and substituting. This bit's should be very familiar. Part E is probably the hardest part, where you need to think about both the vertical and horizontal components of the velocity, and then just add them together using Pythagoras' theorem. Yeah, that's it. That's question 4. I hope you enjoyed it.